Today we will begin our first chapter, sets. In our daily life, we might have heard the word set, group, collection, a lot of times. And today we will define set in mathematically. Today we will define set mathematically. A set is a well defined collection of objects. So let's focus on this word well defined. A well defined collection is something which is not ambiguous or confusing. So for example, if I say a set of first three natural numbers, so that's a very well defined collection of objects because we know that we are referring to the first three natural numbers. But instead if I say a set of three natural numbers, this is not a well defined collection because three natural numbers could be anything. It could be 4, 5, 6, or 7, 8, 9, or 11, 15, 17. So this is not a well defined set because the definition says it's a set of three natural numbers and that can have different permutations of numbers. So that's not a set. Whereas the first one is a well defined set. Next, we will talk about the notation for sets. A set is usually represented by capital letters. The members of the set are represented in small letters or lowercase letters. And we use the symbol belongs to represent the relation which is um, small a belongs to capital A, which this notation states that this small a is belonging to the set represented by the letter capital A. So for example, A is equal to A comma B comma C. So this is a set of first three letters of English alphabet, and in order to say that A is a part of the set capital A, we represent it in the format as shown above, which is A belongs to capital A. Next we will talk about description of sets. A set is described in two ways. First way is called the roster method and the second is called the set builder method. First, let's talk about the roster method. In a roster method, all the members of the set are listed and each member is separated using a comma and the entire set of elements are included in braces. For example, consider the set of the first five natural numbers. So we'll begin with defining the set as A, and in the roster method we have to list all the members of the set. The set is first five natural numbers. So those are 1, 2, 3, 4 and 5. In a roster method we list every element and each element is separated by comma and the entire set of elements is enclosed in braces and we put an equal to it before that. So that means A equals to set of 1, 2, 3, 4, 5. This is roster method. The same thing can be represented in the set builder form, and in a set builder form elements are described by means of a property which defines those elements. So what do I mean? So let's see that example. So we define the same thing in set builder form as follows. We say um, n belongs to capital N where n less than or equal to 5. So if you look at this, we are saying this is a set of natural numbers where n belongs to capital N. Capital N is the universal set of natural numbers, and we are saying n is less than or equal to 5. So the same thing as 1, 2, 3, 4, 5. So this is the set builder notation, and this is the roster notation of a set. Another important property of a set is no two elements of a set are equal. This is a very important property of a set. So what do I mean? So if I ask you to write a set which is all the letters in the word India, right? So we can start by the word India, and we have to represent all the letters of the word India in the form of a set. So a set is represented using a capital letter, and we are going to use the roster form here, and we'll say I, comma N, comma D, comma A. So if you see here, I have not included the I again because a set will not have duplicates. So I is a duplicate, so we will not include it again. So these are the letters of the word India in the form of a set. The same thing, this is a roster form, right? Same thing can be represented in a set builder form where we can say that X belongs to A such that X is a letter of the word India. So that's the same set but defined in the form of a set builder. The first one is a roster form. Another important property of a set is the order of elements in a set has no significance. So what do I mean by that? So for example, let's consider the set again where we represent the first 5 natural numbers. So that could be represented as a equal to 1, 2, 3, 4 and 5. So this is not, is also equal to 2, 3, 1, 5 and 4. So this is the same set. The order of the elements is just changed, but it doesn't mean that there are two different sets. So in both the cases, the elements of the sets are the first 5 natural numbers. So the order of elements in a set but has no significance. Similarly, take another example in the one which we just did in the previous, which is the all the letters of the word India. So the same thing can be represented as A, N, I, and D. Again, these are all the letters of the word India, just the order is different. So now let us work on some problems. We are given two sets in the form of set builder notation, and we are asked to convert them into roster form. So the first one is x belongs to z, which is integers, such that x cube minus 27 equal to 0. So x cube minus 27 equal to 0 means x equal to cube root of 27, and we know that that is equal to 3. So here the set can be represented as, let can take an example, a equal to 3. If the same thing was x belongs to z such that x power 4 minus 81 equals to 0. So if we were given this set, here we know that x power 4 minus 81 equal to 0, which means x power 4 equal to 81, x equal to 4th root of 81, which is plus or minus 3. So in this case, the set would have been minus 3 comma 3. So let's work on that second set. A belongs to A, capital A, such that small a is a letter of the word America. So, and again, we can represent the set with capital A, and we have to define the members of the set, and the members of the set here are letters of the word America. And one of the important rules of a set is a set will not have duplicate members. So if in the letters here, if you observe, A is repeated 2 times, so we have to make sure that we represent only one A, and the members of the set are usually represented in small letters. So A, M, E, R, I, and C, because the last A will be a duplicate. So these are the members of the set, each separated with a comma and enclosed in braces, which is in the roster form. So this is how you convert a set in a set builder form into a roster form. Let's work on few more problems. Here the sets are represented in the form of roster form, and we are asked to convert them into a set builder notation. Okay, let's start by solving the first one. Here we see that set A is equal to uh, all the integers from -3 to 3. So we can represent this as A equals to x belongs to capital Z, which is the universal integer set, such that x is -3 less than or equal to x less than or equal to 3. The same thing can also be represented as x belongs to Z such that x square is less than or equal to 9. Right? If you consider this, x is integer, so if you start with -3 is 9, -2 is 4, -1 is 1, 0 is 0, 1 is 1, 2 is 4, and 3 is 9. Anything below -3 or above 3 is either less than or equal to, or either greater than or equal to 9, or so anything less than -3 or greater than 3 would be greater than or equal greater than 9. So anything less than -3 or greater than 3 would be greater than 9. So this would be the set in the roster form, which is exactly equal to what we have above. So similarly, number 2, if you observe, these are all multiples of 5 until 25. This can be represented as 5x such that x belongs to n and x less than or equal to 5. So the elements that satisfy this condition are 1, 2, 3, 4, and 5, which multiplied by 5 would give us 5, 10, 15, 20, and 25. 5, 10, 15, 20, and 25, which is nothing but our set in the roster form as defined above.